What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. This is part 14 of our Pandas tutorial series in Python. So, for this session, I should mention that we are reaching the end of this tutorial series itself. We have a few more videos to go, but for this session, we did speak about this in a previous video, right? I did show you how what this is and how it works, but I just want to dedicate an entire video now to showing you the various tools and techniques and how we can employ this little technique that I'm about to show you. It is called hierarchical indexing. Okay, so let me type that down for you. Hierarchical indexing. So we spoke about how you can have multiple levels of indices. You guys know, in the header row as well as in the indexer column. And you see, hierarchical indexing, the main goal, you may ask now, what is the point? So the main point and the main goal of hierarchical indexing is to bring about more order, a higher level of structure in the data. Okay, because the whole point of having indices for a table is to allow us to query it easily. Okay, it makes the search operations easier. Okay, so having an index that follows the pattern of a hierarchy, it allows us to kind of trace the data, okay, on a much more in-depth level. So first things first, I'd like you guys to import pandas as pd. And now what we shall do is I will demonstrate first on a simple series object. Okay, so let us work with a series, pd.series. What I'd like you guys to do is import numpy as well. We'll actually use numpy for generating the data itself. So next, what I'd like to do for the series itself, numpy.random.randn, and we'll pass 9. Now this is the part I am focused on, the index itself. This is what I want to show you guys. Okay, go ahead, create a 2D array here, a 2D array, so 2 levels of square brackets. In the first little sub array, what we are doing is we are passing the outermost index column, okay, the outermost indexes or the indices. So for the outermost indices, I will have 3 A's, A, A. Next, I'll have B, B, and let's do C, C, D, D. So we have A, B, B, C, C, D, D. That's the indices we passed for the indexes. Now, I want you guys to create another sub array inside the 2D array, and I want us to assign these numbers 1, 2, 3. Let's do 1, 3, 1, 2, 2, 3. So go ahead, guys, print this and observe what output looks like. This now is the basics of understanding hierarchical indexing. Okay, so basically it's where you have 2 or more levels, index levels, on one axis. Axis as in the row axis or the column wise axis. Okay, in this case we are applying it to the column, the indexer column axis. So let us do this, and this is what we observe. Okay, the indices that we have passed have been kind of structured in such a way where when we look at this series object, remember this is a series object, and we see that there are 2 levels of indexes for the indexer column. That is the concept of hierarchical indexing. Okay, redundancy is removed. Therefore, it makes it easier to query the data. It gives it more structure. Okay, so that's what we have there. Just to remind you guys, all operations that can be performed on a normal series and data frame object can be performed on a data frame and series object that has signs and displays signs of hierarchical indexing. So just to give you a bit of insight, right? We call this method before. We are familiar with this method. It's called the dot index method. Now, what I'd like to show you when you print this to the screen, have a look at the indices themselves. You see, during our initial stages with this Pandas tutorial series, we were introduced to an object called index. Now have a look at this object. This object is a multi-index object. Okay, it is basically an index object, but the word multi tells us that, you know what, there's more than one level of index values for this specific data that we are working with, and that's why we give the name hierarchical indexing, because it's kind of like a hierarchy. You've got the outermost, the innermost, and so on. So that's fine. Now what I'd like to show you is how you can select subsets of data. Okay, we are attempting to select subsets of data from a hierarchical indexed series. Okay, so let me show you how this works. As you see, I've printed the original to the screen for you, so we have an idea of what we are doing. So now print data. I have several indices to choose from. What if I return index B? Let us see what happens. So data, and in square brackets I pass B. And as you guys observe, we obtain those two rows that fall under the outermost index for B. Okay, if there were 5, 6, 7, we'd get returned all the rows for the outermost index B. So that's one way of selection of data. Now, we did slicing operations as well before. Now let me show you how it works on a hierarchical indexed series object. So we'll do all data from B up to C. You guys should remember that C is going to be included. Okay, when you are slicing your series and data frame objects, the stop index is also included. So as you see, we get returned B and C. That's fine. Now what else can we do? We can do print data.lock. So you guys know lock uses the explicit index values. Explicit as in the labels, the strings that we assign. Okay, that's lock. So what we're doing now is data.lock, and I want to do B as well as C, and this will return to us the same output or result as the slicing operation. Okay, it's just that you may ask and you may wonder what is the difference between these two operations, because the output is the same. Is there no difference between them? There is a difference, guys. You see in this here, I'll uncomment this line. This line here, we did a slicing operation. How do we know this? Because of the colon. And in the bottom operation here, we did a fancy indexing operation. We have passed multiple index values to get returned multiple values from the source data. In our case, the source data is the series itself. So this is fun, right? But what we did here is we have indexed from the outermost level. The outermost level as in, so data, you see A, B, C, and D, they form the outermost index. Now we have an inner index as well. 1, 2, 3, 1, 3, 1, 2, 2, 3. So we can also select from the innermost index. Let me show you a small demonstration. Print data.lock. I'd like to return all rows from 2. So as you guys will see, this is what we obtain. Now what's important to understand, right, is all rows and 2, right? That's what we have just returned. Now let me explain to you what has actually occurred. Now if you look carefully, right, if you look closely at the data itself, I'd just like to mention to you that each time you run the script, the data is changing. Please don't forget about that, guys. And you may ask, why is the data changing? It's because we are randomly generating numbers. So you guys can actually go ahead and pass a random seed if you'd like to have consistent results. Anyway, what we have just done here, we have collected, or we have retrieved all those values from the original series object, in which the innermost index has a value of 2. Okay, if you are confused, look at the output, right? In the original series, How many 2's we have? We have a 2 there, so that's 1. We have a 2 here as well as there. So that's 3 2's. And notice in the output we receive, we have 3 values. And these values are the corresponding innermost index and their associated value. So 2. Now, if I had to change the 2 to maybe, let's do 1, you guys are going to notice that. So let me not run the cell again, that would generate new data. I'll do data.log all rows that match with an innermost index of 1. So we should expect to see 0 0.2, negative 0 0.2, as well as 0 0.6. So I'll do enter, and that is exactly what we see: 0 0.2, negative 0 0.2, and 0 0.6. So that's the concept of selection, but using the innermost level of the indices. Now, that's fine. What I'd like to show you, right? This is actually a cool method. It is built in Pandas. It can be called on a series of data frame object. Now, I'd like to show this to you. You see, hierarchical indexing plays a very important role in reshaping the data, okay? And, kind of grouping the data together. It forms like a pivot table, okay? Now, what I'm saying is that this series that we are working with, really, logically speaking, we can rearrange the data in a data frame, okay, instead of using the series itself. So let me show you how this works. So print data, let me comment that up there. So that is data for you to view. Now there's a method called unstack, okay, data.unstack, and all we need to do is call this without passing any parameters to it or arguments, okay. Leave everything as default, and what it does is, you see, a series that has a multi-index on it, and we know for a fact that this series we are working with has a multi-index. This series, what the unstack method does, it's going to take the series with the multi-index and it's going to produce a data frame. The process is performed entirely by Pandas, so we don't have to stress about that. Now let me show you. This is what we obtain. It has effectively unstacked or kind of unraveled the various levels in the hierarchical index, and it has produced us with a very neatly formatted data frame object. So that is what we see there. Okay, that's the unstack method for you. Feel free to play around with that. Now you may ask yourself, so I just showed you the unstack. Let me show you something cool, right? Unstacked is equals to data.unstack. So if I print unstack, you guys know we'll see exactly what we saw before. That's fine. Now you may be wondering, is there a way to kind of get the unstacked data frame into the stacked, representation? And you can, guys. It is possible. You see, the opposite of the unstack method is stack. So let me show you. Print unstacked dot stack, and again call it without passing any arguments to the parameters, and you guys see it builds the multi-indexed series object for us. Okay, so that's how it works. Now that is cool. Now I'd like to show you a multi-index on a data frame object. So we've just seen hierarchical indexing in action on a series object. You are probably wondering, what's it like on a data frame object? So let me demonstrate really quickly for you. We'll do import pandas as pd, import numpy as np. Okay, so let's call frame is equals to pd dot data frame, and within this I'll do numpy dot arange 12 dot reshape. Let's reshape this to 4 by 3. Now for this I need to provide index value. So again, guys, create a 2D array, and let's do this together. What I'll do now, this is the indexer column. Okay, on the left of the data frame itself, we are providing the index levels there. So let's keep it simple. Let's do A, B, B. That's the first level of index values. For the second level, I'd like 1, 2, 1, 2. That's good. Now, the next cool thing, columns is equals to, create a 2D array here as well, guys. And this is where you realize that with a data frame, due to its representation, it has, it's basically two-dimensional, and that is why you can set a multi-index to be for the column axis as well as the row axis itself. So you can set a multi-index for the header column, for the header row and the indexer column. So let me show you. What we'll do is we'll set Ohio, Colorado. That's the first level of indices. For the next level, let's do, so just some random colors, green, red, green. That's good. Now print frame. When I print this, you guys are going to see a very different, in inverted commas, data frame that is really very powerful. Why? Because it has a multi-index on it. Okay, so this is what we observe. This data frame has hierarchical indexing. How do we know? Because if you look at the header row as well as the indexer column, we can see that there's more than one levels of index values that are attached to this data frame object. So that is cool. Now, let me show you something even cooler. You see, guys, if you are following along, if you have been following along with this tutorial series, you'd know that we had the ability to actually name the header row and the indexer column. Now, with the multi-index, you can also do that. Okay, you can do that. And the thing is, the cool thing is that you'll have to name each level of the multi-index. So really, that's just more metadata that makes the data frame object so much more, self-explanatory. So let me demonstrate this for you. We'll do frame.index.names is equals to, now I am passing names for the header, for the indexer column. There are two levels here, so I need to provide two names. In a single dimensional array, I'll do key 1 and I'll do key 2. Okay, that's for the indexer column. Now it is time for the header row. What I'll do is frame.columns.names is equals to, and I can provide state. So the first level is state. That's this level here, Ohio and Colorado. That will be assigned the name of state. And the innermost level, green, red, green, I'll provide that with a name of color. Okay, so that's good. Now, let us print the frame itself to the screen, and you guys are going to see that now we see these little labels for the indexes themselves. So the innermost, the outermost level of indices here have been assigned the name of state. Innermost here has the name of color. The outermost index row for A and B, or column rather, for A and B has been assigned key 1, and the innermost indexer column has been assigned key 2. So that is cool, and I do encourage you guys to play around with these. It's really very interesting. So anyway, you see, suppose now I just want to obtain a single column from the data frame. Now it's good to know, guys, that the way in which you index and slice and so on does not change. It remains the same. Okay, the operations that we have been performing on a single indexed series and data frame object, the logic is the same. Slicing will work, booleans will work, and so on. So just to show you, frame, suppose I wanted all data pertaining to the Ohio column. So I'll do frame Ohio in square brackets, and that's what I obtain. Okay, the red and the green. So that's fine. Now, what I'd like to show you is another cool thing. You see, sometimes, so this falls under the category or topic of reordering and sorting the levels of indexes. Okay, now You see, guys, oftentimes we may need to rearrange the order of the indices, okay, the levels on a certain axis or so on. Or we may be required to sort the data by the values in one specific, index axis. Now, this is where we have introduction, or we meet a method that calls swap level method, and it will take two level numbers or names, and it will return a new object with the levels that are changed, but the data itself is not affected, it is not altered, it is not changed. So let me show you a small demonstration. I'll do print frame dot swap level, and within this, so let me pull up the documentation. You see, we need to provide two values, I and j. Okay, so let's assume now that, let me pull up frame again for you. This is the frame we have, key 1 and key 2. What if I wanted it such where key 2 was the outermost key and key 1 was the innermost key? So what I'll do is I will basically provide the names of the indices or the indexes that I'd like to swap. So I want to swap key 1 and key 2. Now what this will return is a data frame where key 1 is no longer the outermost index. Key 2 becomes the outermost index and key 1 becomes the innermost index. So if I run this, you guys see key 2 is on the outside, key 1 is on the inside. And as I mentioned, the data itself did not get affected at all. Pay attention, guys. This is the original data frame. It did not get, the data we see in the reordered data frame, it did not get changed or altered in any way. So that's the swap level method for you. It is powerful. Now, we have seen this method before. It is called sort index. Okay, sort index. Now, all this does is it sorts the data using the values in a single index level. Okay, so let me show you what I mean by this. Print will do frame dot sort index, and we'll do axis. So maybe let's do level, we'll leave axis to equals 0, but we'll set level to be equals to 1. Now this is frame, that's the original data frame, and now when I print this, pay attention to what happens, guys. So we now have this data frame, and if we look closely at the key 2 index values, there is something that we can notice as opposed to, the original data frame itself. Key 2 in the original took the form of 1 2 1 2, but now by sorting the index values, what we observe and what we see is that key 2 has been sorted in ascending order. Ascending order means smallest to biggest. That is why we see 1 1 2 2. So that is the concept of sorting the data in a data frame. Now let me show you something a bit more cooler. So you see, this data frame that we are currently working with, you'll agree with me, right, that it has levels. It has levels of indices. Now, with that being said, you guys know we have performed some summary, some descriptive and, statistical computations on a data frame, but we did not do it on a multi-indexed data frame. Now, this is where the power of combining statistics with a multi-indexed data frame comes into play. Because you see, with us having different levels in the data frame, we'd have the ability to specify the level that we want to perform a certain aggregation or kind of operation on. Okay, so considering our example of frame, you guys see this is frame here, the data frame that we have. Suppose now I want to sum, so sum frame dot sum level is equals to, and I can pass key 2. I am summing the values in key 2, and we can sum either by the rows or the columns. And just to pull up the documentation itself, so as you guys see, these are the parameters. Now let me show you. So this is what we see. We have this little kind of aggregations that have been returned to us, and essentially if you look carefully, what you'll notice, right, is that key 2 is the one that is showing, because that is the level by which we are summing. And the thing is, if we look at green, for example, right, key 2 for the value of 1, so key 2, there are two ones, and we see 6 plus 0 gives us 6. Now for the red, so we have the one here, that is 1, and this one here plus 7 gives us 8. Okay, so you guys know I'm doing this step by step. I am tracing out what's happening for you, because I don't want you guys to get confused. The whole point of my tutorials are for us to all learn and enjoy the process. So that's what we see. I'm just tracing how the summarization of the data has took place. So the level we specified, think of level as index. Index is equals to key 2. So it took key 2 and all the keys inside key 2, and it attempted to sum it. So that is what we observe in the output that we see. Now that's fine. That's one way of doing things. Now, what I can do as well is I can specify axis. You guys know we have worked with axis before. Column axis is equals to 1 is column wise, and 0 is equals to row wise. So let's do a print frame dot sum level is equals to color, axis is equals to 1. I'm pulling up frame again for us to see. This time we are doing it on color. Axis that we are doing it on is by the column or by the row. So let me show you how this works. You guys will see. Before we even look at output, this is the frame we have. Axis is equals to 1, telling us now that we'll sum the columns horizontally. So what I'm saying is level is color. Color is here. So we'll do it such way we see now that green. So green, we have 0 plus 2, that gives us 2. Red, well, there's nothing to add red to, so we see 1. Next, we have 3 and 5, that gives us 8. 4, there's nothing to sum for the red, so red will remain the same. But greens, however, greens will not. We see for B1, 6 plus 8, that gave us 14. For B2, 9 plus 11, that gave us 20. So that is the concept of summing according to a certain index level. Now that is fine. What I'd like to show you next is the concept of indexing with a data frame's columns. So let's create a new cell. The concept, or let's just say indexing with a data frame's columns. So go ahead guys, import pandas as pd, import pandas as pd. Let's create a data frame object, set this equals to data frame, and within this a dictionary shall do. We'll do a, and I'll set that equals to a range of maybe 7. Next I can do b, I can set this to a maybe range of 7, stop at 0 and steps of -1, that will make it count backwards. Next I can do, let's do C. So C, I can set this equals to, yes, colon, and then I'll do 1 1 1, let's do 2 2 2 2. Okay, that shall do there. That's the data that we have. Now what else I would like to do is just add one more column here. So let's do D, and I'll make these values, we can set them equals to 0 1 2 0 1 2 3. 0, 1, 2, 0, 1, 2, 3. Now, go ahead, print the data frame to the screen, guys. And what you will see is a kind of, sophisticated data frame that we have here. All right, it's a basic one. We have dealt with these in the past. It is a simple dictionary creation. Okay, so that's fine. Now, the topic of this cell is indexing, but with a data frame's columns. Okay, now you see this data frame that we have here, there's no multi-index that we have set on it. Okay, there's no multi-index at all, but we can set a multi-index. So let me show you how we can use columns from the data frame to become the indexer column. So this is something I've showed you before. This is just a recap. Frame2 is equals to frame.setIndex, and within this we shall pass the indices, the columns from the original data frame that we'd like to use for the indexer column. So I'll do C and D. Okay, so print frame2. When I run this, you guys are going to see C and D are going to become the indexer column on the extreme left of the data frame. The data frame will only have the remaining columns, which are A and B, that's storing data, okay, the values themselves. So, and this is what we see, guys. So we have effectively used a data frame's columns to become the indexer column. So that is what we see there. Now, what I'd like to tell you and mention to you is, you see, by default, okay, in the way in which we just did things here, by default, the columns that we used for the indices, they were removed from the data frame, right? As we can see, C and D have been removed from the columns because now they have been shifted to become the index. But if you don't want the columns to get removed every time you use certain columns for the indexer column, you can keep those columns in the data frame. The way in which you do that is as follows. So let's suppose we have this object called frame3. We're going to set this equals to frame.setIndex, and I'll pass again C, D. But this time I don't want these columns getting dropped from the data frame. If you look carefully, you'll see there's a parameter called drop, and by default it's set to a value of true. Now all we need to do is set drop is equals to false, and when I print frame3, you guys are going to see that C and D did not get removed from the data frame. So that is cool stuff right there. Now that is about it that I want to show you for the video. If there is one more thing that I'd like to show you, it's how you can actually undo the setting of the indexes. Okay, so print frame2. This is the indexes that we have here, the indexer column. We've set this. Now if I didn't want that to show how I manipulated it, I can show it in the original form. All I do is the name of the data frame dot reset index, and when I run this, you guys see the data frame gets restored back to its former version. So that is good stuff right there. Now that's all that I want to show you for this video, guys. We have done a lot of cool stuff. We are just continuing expanding our knowledge about the Pandas package in Python, and that is excellent. So this is about it for the video, and I'll probably do one last video pertaining to Pandas package in Python, and then we shall end this tutorial series. We have covered a lot of cool and interesting concepts pertaining to data frame. So yeah, this is where I say goodbye for the video, guys. Thanks for watching. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.